Need to talk about parallel circuits. Parallel circuits are similar to series circuits in that there's in a parallel circuit, the voltage is going to be the same across each device, and the current is going to have more than one path to follow. So your current could go straight, it could duck down there, it could continue going straight, or it could duck down here, and then it continue going around this corner. And so when you see a problem and they don't tell you whether it's parallel or series, if you see the term voltage across, that means you're using a parallel circuit. Okay, this is how most things in your house are set up, because you don't want things in your house to be set up in series, because if one thing goes out, everything goes out. And so we set up our houses in parallel, because then if this thing stops working, the energy or the current can still get to the other items in your house. And so if one thing goes out, everything in your house won't go out. To calculate the equivalent resistance of a parallel circuit, it's basically equal to the sum of the reciprocals of each individual resistor. So if I were going to take each individual resistor, I could put them down here, and I could get I would get 1 over R equals some number, and then you'd have to solve. You'd have 1 equals, and then you'd still have to divide by that number in order to get R by himself. So let's try a parallel circuit problem. We have 3 resistors, 60 ohms, 30 ohms, and 20 ohms, and they're connected in parallel across a 90-volt battery. And so we want to find the current through each branch of the circuit. So to do this, we have resistor 1 is 60 ohms, resistor 2 is 30 ohms, and then resistor 3 is 20 ohms, and the voltage is the same across the entire circuit, so the voltage is going to be 90 volts. Okay, so in order to find these, we're going to start with one resistor and we'll just go on. So we have our current is equal to our voltage divided by our resistance, and that's going to be our first current and our first resistance. So we'll have 90 volts divided by 60 ohms, and we'll get 1.5 amps. So that's going to be the current in the first resistor. Now, if we want to go to the second one, we will have our voltage divided by our second resistor. The voltage is still 90, and the second resistor is 30. So we end up with 3 amps. And then for our third resistor, our third current is going to be equal to the voltage divided by our third resistor. So our voltage is 90 volts, and our third resistor is 20 ohms, and so we'll have 4.5 amps as our current. And so this is the current through each branch of the circuit. Now we have this same problem. We have our 3 resistors, except now they're asking for the equivalent resistance. So if we want to write the things that we know, we know our first resistor is 60 ohms. We know the second resistor is 30 ohms. And we know the third resistor is 20 ohms. So if we want to find the equivalent resistance, we're going to use this formula. The equivalent resistance, or 1 over the equivalent resistance, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R1 is 1 over 60 plus 1 over R2 is 1 over 30 plus 1 over R3 equals 1 over 20. Now when you put these in your calculator, if you want to put them in your calculator all at once, you need to put parentheses around each one, or your calculator might not give you the right answer. And so then you'll have 0.1 is equal to 1 over R. I'm going to multiply both sides by R to get them on the top. And then I'll have 1 is equal to 0.1 times R. I'm going to divide both sides by 0.1, so R really will be by himself now. And I'll have 10 ohms equals R. And that's my equivalent resistance, 10 ohms. Now, if I wanted to find the current that's actually going through the battery, I can do that. Okay, so I have my equivalent resistance, which was 10 ohms. I have my battery with a voltage of 90 volts, and then I want to find the current. So to do this, I'm going to use this formula. Okay, you might have seen this formula as R equals V over I. I just put it in the triangle. Okay, so now I'm going to have my voltage of 90 over my equivalent resistance of 10 ohms, and I'll just have 9 amps as the current that's going through my battery. Now I want to talk about some safety devices in circuits, and this is